Right on the topic, dual nature of radiation and matter. So in this topic, listen. So in this topic we are going to talk about Planck's theory. Right on. In this topic we are going to talk about, the first one is Planck's theory. Second one is photon. And third one is photoelectric effect. And the fourth one is de Broglie's theory. I will repeat it. Planck's theory, second one is photon, and third one is photoelectric effect, and fourth one is de Broglie's theory. Okay, right on the first topic, Planck's theory. So since we are talking about dual nature of radiation and matter, in Planck's theory we will talk about what is radiation and what is matter. Right on. In Planck's theory we will talk about radiation and matter. So under radiation there are two things. The first one is particle nature, and second one is wave nature. Under matter we are talking about two things. The first one is matter wave, and second one is particle nature, matter wave and particle nature. Under matter wave and particle nature. Okay, so under radiation two things, no, particle nature and wave nature. So under particle nature we will talk about the photon. So write down the point under photon. It is chargeless particle. Which means Q is equals to 0. Photon is chargeless particle which is Q is equals to 0. And the next point is rest mass is 0. So chargeless particle and rest mass is 0. So under wave nature we will talk about electromagnetic waves, EM waves. So this was the thing we have discussed in the morning class, right? No, electromagnetic waves. Okay, so if we talk about a photon, like obviously if it is a rest also it will consist of energy, Okay, write down under photon. The other point is it consists of momentum as well as energy. It consists of momentum as well as energy. It consists of momentum as well as energy. So the formula is nothing but E is equals to hc by lambda. E is equals to hc by lambda, or else the other formula is h into mu. H into mu. So here mu is nothing but the frequency, lambda is nothing but wavelength, c is nothing but speed of the light, and h is nothing but Planck's constant. Okay. So till now we have discussed 4 topics, like we are going to discuss the 4 topics. The first topic, under first topic, the radiation and matter we are discussing. So under radiation 2 things are there: particle nature and wave nature, and matter, wave and particle nature. Okay. So under particle nature we are going to discuss about the photon. So which has the q is equals to 0 and rest mass is 0. So and then it will be having momentum as well as energy, and formula is E is equals to hc by lambda, or else h into mu. Okay. And wave nature we are discussing about the EM waves. So that one we have completed already. Okay. And we will go for the matter waves. Matter waves. So under that we will discuss about de Broglie's. Under that we will discuss about the de Broglie's theory. So in that the formula is lambda is equals to h by p. Lambda is equals to h by p. So what is the value of Planck's constant? 6.63 into 10 power minus 34. 6.63 into the value of h, the Planck's constant. 6.63 into 10 power minus 34, Planck's constant value. Done. So what are the 4 topics I have told? First one is Planck's theory, photon. Third one is photoelectric effect, and then de Broglie's theory. Okay. So under first one only we have the radiation and matter. Under radiation we have talked about the photon also. Okay. 2 topics has been completed. The third one is photoelectric effect. Third one is the photoelectric effect. Write down the point. It gives us the relation between photon and electron. Photon and electron in bracket interaction. Interaction in bracket you can write interaction. Done. The next point, it gives us the particle nature of EM waves. It gives us the particle nature of EM waves. Okay. So this is the intro about the dual nature of radiation and matter. Okay, we will go into the topic now. Suppose if there is a metal and any photon is interacting with the metal. Okay, so metal is nothing but obviously there will be a free electron on the surface of the metal. Okay, if a photon is interacted with the metal, that free electron will eject from the metal surface. Okay, so and obviously there will be a free electron on the surface. So if there is a incident rays, that is light, obviously it will be having energy, no, E is equals to hc by lambda I can take, or else it is h into mu. So after incident it will eject the electron from the metal surface. Okay, take the diagram, I will give the notes. Write down the first point. The metal consists of large number of free electrons, large number of free electrons at the surface, large number of free electrons at the surface. The next point, the light consists of packets of energy. The light consists of packets of energy, that is E is equals to hc by lambda. E is equals to hc by lambda. E is equals to hc by lambda, or E is equals to h into mu. So this is the energy for each photon. Okay, energy for each photon. The next point, after photon incident, it gets interacted with electron, and remove from the metal surface, The next point, so one photon will interact with one electron, will interact with one electron. One photon will interact with one electron. The next point, the minimum energy required to release the electron from the metal surface, is called as work function. The next point, this work function depends on the metal. This work function depends on the metal. For example, cesium, cesium, no? For that work function, like work function is denoted by the letter phi. Okay. Sometimes they used to denote like phi naught also. Okay, work function. So work function for cesium is equals to 2.14 electron volt. 2.14 electron volt. For platinum, how platinum is Pt, no? For platinum it is 5.48 electron volt. 5.48 electron volt. Okay. So for the lowest metal and the highest metal I have given. Next one, visible range for light. The next subtopic, visible range for light. So the range is 3700 to 7980, like 7980, 3700 to 7980 Armstrong. Okay, this is the range. So 3700 for the violet, and 7980 for the red. So if you keep this, remember the formula, no, like the values you can write for the remaining things like VIGR. Okay, it keeps on increasing the visible range. Write down the formula. E is equals to hc by lambda, we know, right? So the other formula is E is equals to, we know the formula, E is equals to hc by lambda, right? No, the other formula, E is equals to 12,400 by lambda. 12,400 by lambda. So 12,400 by lambda. This is in electron volt, and lambda should be always in Armstrong. So example, suppose lambda is equals to 4,000. For example I am giving lambda is equals to 4,000 Armstrong. What is the value of the E? that is energy. Hmm? 12,400 divided by 4,000, no, that's it, no? 3 point 3.1 electron volt. Take down. Okay. So once you see this formulas, whatever we have discussed now, if you are having any doubt, I'll tell the clarification. If you are not having any doubts now, we'll go for the next one. Once you next topic is power. Okay, so since we are talking about the metal surface, no, so when I take the photon which is incident on the metal surface, it releases the electron. So that a light which is coming, no, then I can call that light as source, no, source. Okay, so obviously that source will release the n number of photons. Okay, so if I talk this release n number of photons, write down the points. Power is equals to work done by time. Power is equals to work done by time, or else power is equals to energy by time. These two formulas we know. So from the work, energy and power. Now if a source releases n photon per second, if a source releases n photon per second, then can I call this formula in terms of P is equals to NE? N is nothing but photons per seconds. Okay, here only I am having the value of T, no, so N is nothing but photons per second. So obviously E by T I will get it. Getting the point? So N is nothing but photons per second, which means P by T. For example, if I consider, so P by T into E, so E by T will be obviously the power, and N is nothing but the number of photons. Okay, so N into E is the formula. So if I expand this formula, how can I expand this one? E is nothing but hc by lambda, or E is equals to h into mu. So P will be equals to nhc by lambda, or else n into h into mu. This other formula in terms of Planck's constant and the frequency and like that is wavelength. ఏం అవ్వలేదు మేడం. Okay, listen here. If a photon is coming an incident on the metal surface, no, it will try to eject the electron, that we know. Suppose this is my metal surface, I am giving 5 electron volt, but this electron is required only 3 electron volt, which means I can have only 3 electron volt to reject the electron from the surface. The remaining will be, where it goes? The remaining, this is a total energy, no, this is work function, no, work function. So to give the relation, the Einstein gave the equation E is equals to phi naught plus kinetic energy, that is maximum kinetic energy. Okay, this is the relation. Write down the topic Einstein's equation. Einstein equation, physics తాతయ్య కదా. ఏ ఐన్స్టైను, ఈ న్యూటను ఎవరు లేకపోతే ఫిజిక్స్ ఎందుకు వస్తుంది కదా. అసలు యాపిల్ పడకుండా ఉంటే ఒక రాయి, పెద్ద రాయి పడి ఉంటే పోయింటాడు వాడు. ఏదో వాడు చేసిన వల్ల మాకు ఏదో లైఫ్ దొరికినాయి ఫిజిక్స్ ఫ్యాకల్టీగా అంతే. వేరే జాబ్ చూసుకోవాలన్నా. ఓకే, రైట్ డౌన్. So phi naught is equals to h into mu naught, h into mu naught. Like we'll relate this formula with the total energy, that is E is equals to h into mu, right? Okay, this is frequency, we'll say this is threshold frequency. Okay, mu is nothing but frequency, mu naught is threshold frequency. I'll tell what is threshold frequency means. Take the formula first. Okay, so this is also work function, no, this is also called as energy, no. So this is threshold energy and this is threshold frequency. Threshold means nothing but the minimum. Okay, work function means what? The minimum energy required to eject the electron from the metal surface. So threshold, the meaning of threshold, okay, the basic meaning of the threshold is nothing but minimum. So threshold energy means nothing but minimum energy, threshold frequency is nothing but minimum frequency. Okay, write down. Threshold means minimum, threshold means minimum. threshold కాదు, ట్రాష్ అంటే గార్బేజ్ అయిపోతుంది. Threshold energy means nothing but minimum energy, threshold frequency means minimum frequency. So can I write this threshold energy in terms of lambda also, which means it is hc by lambda naught, which is nothing but threshold wavelength. Okay, so from this no equation can I write hc by lambda is equals to hc by lambda naught plus kinetic energy maximum. So if I want kinetic energy, can I write kinetic energy is equals to hc by lambda minus hc by lambda naught. This one formula. The other formula is kinetic energy is equals to h mu minus h mu naught. Okay, this is in terms of frequency, this is in terms of wavelength. Take the formula. Okay, so for example, the work function required only 3 electron volt, but the energy which has been given by the photon is 3.4 electron volt. Okay, so what is the what is the kinetic energy here? What is the kinetic energy? E is equals to 0.4. From this equation can I get the value of kinetic energy? No, E value they have given and phi naught value also they have given. So which means 3.4 minus 3 will give 0.4. So sometimes they might give the option as 0 less than or equals to kinetic energy less than or equals to 0.4. This also can be represented. Okay, so kinetic energy can be from 0 to 0.4. So the minimum will be 0, maximum will be 0.4. I am talking about for only this question. Okay, so they can give the option like this: A that is kinetic energy is equals to 0.4, or else they can give like it is in the way also. So both are correct. I will stop up to this.